Good morning, students. Chapter 7, System of Particles and Rotational Motions. Yes, we will see some MCQs. See how to solve MCQs. First of all, for a given chapter, you must know each and every concept. And the most important thing is equations. If you know equations very well, then you can easily solve questions. Okay, how to relate some concept one to another, okay, that is also important part. Okay, whenever you try to solve MCQ, first of all, try to understand situation. Okay, what is given? Okay, you can also draw one picture, one drawing of that given situation. Write data. Okay, then from that picture, if you see each and every object, each and every particle, what axis is given, etc., etc., what data is given, then from that you can easily formulate equation. Okay, yes, for this situation I have to apply this equation. Okay, so yes, it's up to you. Okay, how you think, okay, and how you relate question. Okay, so yes, here we will see some questions, MCQs, okay, how to solve from chapter number 7. First question, here it is. The rod, this one, is released from rest in horizontal position. Right now it is in horizontal position. Rod is free to rotate about A. Then find initial angular acceleration of the rod. See, this rod is about to rotate about this point A. Now it is in horizontal position. Okay, if it is in horizontal position, so which forces are acting on it? Yes, here. Its mass is M, its length is L. Okay, so at this point, that is its center of gravity, at this point in downward direction, force acting is mg, that is its weight. That is its weight. Yes, it is its weight. So, due to this weight, it falls down in downward direction. But what you are given? Okay, the rod is released from rest in horizontal position. Rod is free to rotate about A, means this point is this point. Then find initial angular acceleration of rod. And angular acceleration means you have to find alpha is equal to question mark. Now see what data we have. We have only this one. Okay, this rod is of mass M and length L. Okay, mg, that is its weight. It is acting in downward direction, but from point A at distance. Yes, at distance L by. So see, you have one force and one length, that is perpendicular distance. So from this you can say, yes sir, this rod is performing rotational motion. This rod is performing rotational motion. For rotational motion, what is required? Torque. For rotational motion, what is required? Torque. Torque is equal to force into perpendicular distance. So yes, we have force into perpendicular distance. So here, torque, tau is equal to force into perpendicular distance. Why L by 2? Because its center of gravity is here and weight at point center of gravity. Okay, so torque tau is equal to, it is mg L by 2. Now we also know one equation of torque, that is torque tau is equal to I alpha. It is mg L by 2. Now I means moment of inertia. Moment of inertia, its equation depends about which axis object is rotating. See, rod is free to rotate about A, means this rod is free to rotate about this point A. A means it is axis passing from one end and perpendicular to its length. Yes, this axis is passing from one end and perpendicular to its length. And above this axis, what is equation of moment of inertia? It is ml square by 3. Yes, we have proved this, okay, in lecture. So it is ml square by 3. Alpha, that is alpha is equal to, it is mgl by 2. So M cut, L cut, L cut. If you make alpha as subject, then alpha is equal to, it is 3g upon 2. It is equation of alpha. You see, data, 4 choices, 1 figure, but solution on this. Okay, if you know each and every concept, okay, yes, if we release this rod from rest, it will perform rotational motion. So rotational motion is due to torque. So which torque? So it will rotate due to its own weight. It is acting from center of gravity mg distance. So yes, you have to start solution from this one. Okay, torque is equal to, it is force into perpendicular distance. Then tau is equal to I alpha. I, that is moment of inertia above this axis. Your question is solved. Clear? Okay. So yes, it is how to solve MCQ. Number two. Find MI means moment of inertia. Okay. Find moment of inertia of a frame. See, you are given one frame. Okay. This frame is made up of 4 identical rods. Yes, this frame is made up of 4 identical rods. Okay, you have to find moment of inertia of frame about an axis passing through the center and perpendicular to its plane. Chalo, center of frame means this point, and perpendicular to its plane means like this, about this axis. Hai? Yes, about this axis. Okay, now see, for a rod, wait a minute. Okay, if you are given one rod like this, okay, then about an axis passing from its center and perpendicular to its length, means about this axis, we know its moment of inertia, that is IC, is equal to, it is ml square by 12. It is ml square by 12. Yes or no? Yes. Okay. It is one rod. It is axis like this. It is like this. It is axis passing from its center and perpendicular to its length. The moment of inertia about this axis is IC is equal to ml square by 12. If you are given one point here, okay, yes, you have to find about this axis. White chalk. You have to find moment of inertia about this axis. Then what to do? See, these two axes are parallel to each other. Then you can use parallel axis theorem. That is, moment of inertia about this axis, I is equal to, it is IC plus mv square. Yes, it is parallel axis theorem. I is equal to IC plus md square. Yes. Now, for this frame is made up of 4 rods. Yes or no? Chalo, first rod. Here. It is axis passing from its center and perpendicular to its length. You have to find moment of inertia about this axis. So these two axes are parallel. Yes. Okay. Similarly, for this rod. Okay. It is axis passing from its center and perpendicular to its length, and this axis parallel. Yes or no? For this rod, these two axes parallel. For this rod, these two axes parallel. Yes or no? Yes. Yes or no? Yes. Okay. Plus, see, these 4 rods, they are identical. Their mass equal, their length equal, and from this each and every rod, distance of center is also same. So yes, moment of inertia of rod about axis passing from center and perpendicular to plane, I is equal to 4 times IC plus md square. Why 4 times IC plus md square? Do you understand? Due to this rod, due to this and this. Okay, chalo. So is equal to, it is 4 times IC means it is ml square by 12 m. D, what is distance between these two parallel axes? These two parallel axes, these two parallel axes and these two parallel axes, obviously as it is square it is L by 2 whole square. Any doubt? Okay, so is equal to, it is 4. Chalo. It is ml square by 12 plus here it is ml square by 4. Here it is ml square by 4. Any doubt? Okay. Okay. So now how to simplify this? How to simplify this? If you multiply 4 inside, okay, then it will also solve. It is ml square by 3 plus it is ml square. And yes, it is 1 by 3 plus 1 means it is 4 by 3. So it is 4 ml square by 3. It is 4 ml square by 3. And yes, it is your answer. Yes, it is your answer. Okay, what is your answer? Your answer is, it is 4 ml square by 3. 4 ml square by 3. Clear? Okay. So yes, it is second question. Chalo. Now next question. Here it is. The instantaneous angular position of a point theta is equal to 2t cube minus 6t square. The torque becomes 0 at blank second. 1, 0.5, 0.25 or 2. Torque 0. Yes, you are given theta, and what is condition? Okay, torque becomes 0. Torque is 0. Chalo, we will write equation of torque. Okay, torque tau is equal to 0. Is there any relation between tau and angular position? Huh? Tau. Chalo, first of all, try to remember equations of torque. Tau is equal to, okay, sir, yes, from this. We can say, sir, tau is equal to, it is force into perpendicular distance. Force and perpendicular distance. From theta, can you find what is force or perpendicular distance? No. But you have another equation of torque, that is tau is equal to I into alpha. Alpha, what is alpha? Alpha is angular acceleration. And yes, you are given angular position. So from angular position, first of all, you can find angular velocity and then you can find angular acceleration. Yes. Okay. So see, as torque tau is equal to 0, torque tau is I alpha is 0. So therefore, alpha is equal to 0. Alpha, what is alpha? Alpha is called angular acceleration. Alpha is called angular acceleration. So first of all, from equation of angular position, see, angular position, that is theta is equal to 2t cube minus 6t square. Find angular velocity. That angular velocity omega is equal to, it is d theta upon dt. Chalo, you know differentiation, okay? Chalo, 2t cube means it is 6t square. 6t square means it is 12t. Yes. Okay, so it is angular velocity. Now you have to find angular acceleration. So angular acceleration, alpha is equal to, it is d omega upon dt. So again differentiation. 60 square means it is 12t. 12t its differentiation, it is 12. But you are given that torque tau is equal to 0. It means alpha is 0. So put alpha is equal to 0. It is 12t minus 12. So therefore 12 is equal to 12t, and therefore t is equal to, it is 1 second. Therefore t is equal to, it is 1 second. Clear? Okay. So yes, first of all, try to understand concept, which concept you have to apply. Okay. Write down from what? We will see next 3 questions. Okay, next question. See, I1 is moment of inertia of a uniform rod about an axis perpendicular to its length and passing through its one end. Ring is formed by bending the same rod. If the moment of inertia about the diameter of ring is I2, then find ratio of I1 and I2. See, understand question. I1 is moment of inertia of uniform rod about an axis. See, first, you are given a rod. Let mass of rod is M and its length is L. About an axis perpendicular to its length and passing through its one end. So suppose it is one end. And about this axis, its moment of inertia, we know that, okay? K about axis passing from and perpendicular to length. I1, okay, we have proved in theory, that is, it is ml square by 3. I1 is equal to ml square by 3. Okay. Now, ring is formed by bending the rod. Means from this rod, if we bend this rod, a ring is formed by bending this rod. Okay. Now ring means, see, it is one-dimensional object. For one-dimensional linear object, okay, its dimension is length. For ring, what is dimension of ring? Yes, it's radius. So let it is its radius r. Mass, from this rod as ring is formed, its mass is m and its radius is r. Okay. So first of all, you have to make one relation between length of rod and length of ring. As it is made up from the same rod, I can write, you can also write, okay, K length of rod is equal to length of ring. What is length of rod? L. Length of ring means circumference of ring, and that circumference of ring is 2 pi r. So now make r as subject, then r is equal to, it is L upon 2 pi. Clear about this? So this radius of ring, r is equal to, it is L upon 2 pi. Now see, if the moment of inertia about the diameter of ring, yes, you know this, okay? Okay, moment of inertia about diameter of ring, that is I2. Its equation is, it is mr square by 2. Yes, about diameter, it is mr square by 2. R, what is R? It is L upon 2 pi. So it is m by 2. L upon 2 pi, you have to do it square. Okay, so it is L square upon 4 pi square. Any doubt? Okay, so therefore here it is I2 is equal to, it is ml square upon 8 pi square. You have to find I1 upon I2. So now next step is to find I1 upon I2. I1, here it is ml square by 3. I2, right inversely. Okay, it is 8 pi square upon ml square. So ml square cut, ml square cut. Means I1 upon I2 is equal to, it is 8 pi square upon 3. And it is your answer. Clear? Okay, so yes, this point is important. Okay, length of rod is equal to, it is length of ring. Clear? So yes, it is one question which is based on moment of inertia. Okay, chalo next question. What is next question? If the linear density of rod of length 3 meter varies as lambda is equal to 2 plus x, then the distance of center of gravity of the rod is. Now see here, this lambda means linear mass density. Lambda is equal to 2 plus x, means mass is not constant throughout the length. Mass is not constant throughout the length. If mass is constant, okay, for example, if mass is constant like this, then its center of mass is obviously obviously at its geometrical center. Okay, for uniform linear density, for uniform linear density, but here lambda is equal to 2 plus x is not uniform linear density, not uniform linear density. Okay, it means in some region, or see, as x increases, its density increases. Density low increases, increases like this. Clear? Okay. So for this 3 meter long rod, you have to find what is center of gravity. We know equation. Okay. K, position of center of mass. We know its equation. Okay. X center of mass. Why only X center of mass? Because this rod is one-dimensional object, and for one-dimensional object you have to take only one component. Okay, that is X center of mass. What is its equation? Yes, we know its equation from theory. It is integration x dm upon integration dm. Yes, integration x dm upon integration dm. Now what is dm? We know x. Integration dm means it is lambda dx divided by integration, here it is lambda dx. Yes, remember 3 theories. Okay, linear mass density, surface mass density, volume mass density. In first theory, for one-dimensional object, dm is equal to lambda dx. For 2-dimensional object, dm is equal to sigma dA. For 3-dimensional object, dm is equal to rho dv. Here it is rod, means it is 1-dimensional object, so dm is equal to, it is lambda dx. Clear? Okay. So now put value of lambda. Where is lambda? It is 2 plus x. So is equal to, it is integration x lambda plus x dx divided by, here it is integration lambda plus x dx. Okay. Okay, I can again simplify this term, that is, it is equal to, it is integration lambda x plus x square dx. Sorry, it is 2. Yes, it is 2. Yes, it is 2. So it is 2x plus x square. It is 2x plus x square dx divided by integration 2 plus x dx. Clear? Now see, integration is with respect to x. X means distance. As distance varies, means from this end to this end. From this end to this end. It is nothing but length. Means what is limit? Limit is from 0 to 3. Limit is from 0 to 3. Now take integration. What is integration of 2x? It is 2x square by 2. Plus of x square, it is x cube by 3. Limit is from 0 to 3. Divided by, in denominator, integration of 2, that is 2x, plus integration of x, that is x square by 2. Again, limit is from 0 to 3. Any doubt? Okay. Now put limit, that is, see here 2 cut. So here it is 3 square plus 3 cube divided by 3. Then minus 0, divided by, here it is 2 into 3 plus, here it is 3 square divided by 2. Okay? Okay, so yes, here it is 3 square means it is 9 plus 3 cube divided by 3 means it is 3 square means it is 9 divided by 3 into 6 plus 3 square means 9, 9 divided by 2, yes it is 9 divided by 2. Okay, so is equal to it is, yes, now you can simplify this. Okay, yes, you can simplify. Yes, clear? So yes, it is one question. Okay, it is one different type of question, yes, that we have observed. Okay, if you are given linear mass density, then how to solve such question? Similarly, there are some questions possible with surface mass density and volume mass density. Yes, if you are given equation of sigma, or if you are given equation of rho, yes, equation of rho, then again you can find or you can solve such questions. Clear about this? Okay, so yes, it is again one question which is based on, it is based on center of gravity. Chalo, now next question. Two identical concentric rings are placed perpendicular. Moment of inertia about axis of one of the ring. Now perpendicularly placed means, see, one ring is placed like this. Like this. It is its center. Okay, means it is in this plane actually. Like this. This ring is placed like this. And another ring is placed like this. Another ring is placed like this, vertical. One horizontal and one vertical like this. Okay, see, two identical concentric ring means that centers are at the same point. Placed perpendicularly, moment of inertia of axis about one of the ring. See, it is number 1. It is number 2. So it is called axis of first ring. It is called axis of first ring. Okay, so chalo, we will find moment of inertia about this axis. Okay, moment of inertia about axis of first ring. I is equal to moment of inertia about this axis of first ring and of second ring. Moment of inertia of first ring and moment of inertia of second ring. See, as this axis is axis of first ring, its equation we know that it is mr square. Yes, it is mr square. But this axis is passing from diameter of second ring. See, observe carefully. This axis is passing from diameter of second ring. So what is moment of inertia about an axis passing from diameter of ring? It is mr square by 2. It is mr square by 2. Clear? So yes, it is mr square plus mr square by 2 means it is 3 by 2 mr square. It is 3 by 2 mr square. So yes, you have to understand situation. Which situation is given? Moment of inertia about axis of one of the ring. Yes, I have considered axis of first ring. So this axis, yes, it is axis of first ring, but it is passing from diameter of second ring. So for first thing it is mr square plus for second it is mr square by 2. Addition, it is 3 by 2 mr square. It is 3 by 2 mr square. Clear? Okay, so it is again, yes, one question. Okay, how to find MCQs? Okay, yes, you can change these all questions, okay, by with the help of some another. Okay, in this first question you are given moment of inertia about an axis passing from one end. You may be given, yes, moment of inertia is about from its center of gravity, means from this point. Then yes, the question is changed. Okay, if you are given different equation of lambda, that lambda is equal to, you are given 2 plus x, but if lambda is equal to another question, x square plus 2x plus 3, whatever, okay, then that is a new question. That is a new question. Okay, if rings are placed coaxially means one ring is like this, okay, and another ring coaxially means it is also like this, then moment of inertia will be mr square plus mr square means 2 mr square. Yes, mr square plus mr square means 2 mr square because they both will have same axis. So here it will become, it is 2 mr square for 2 rings. Clear? So it all depends on question. Okay, yes, understand question, try to draw some figure, then you can easily solve such questions. Okay, this is it for today. Now next question, see, a child stands hands at the side on a turntable. The kinetic energy of the table is K. The child now raises his arms. The moment of inertia of system becomes twice. Then the kinetic energy of system will be. You are given two cases for case 1. Okay. K, a child stands hands at the side. Hands at the side like this. Okay. A child stands hands at the side on a turntable. The kinetic energy of the table is K. So initial kinetic energy K is equal to, we know its equation, that is half I omega square. Yes, it is equation of kinetic energy. Now, case 2. The child now raises his arms. Initially his arms are on side. Now he raises his arms. Okay. Then the moment of inertia of system becomes twice, means I dash is equal to 2I. Then the kinetic energy of system will be K dash is equal to what? So what is equation of K? K dash is equal to half I dash omega dash square, because equation of kinetic energy is K is equal to half I omega square. Half I dash omega dash square is equal to K dash. Okay. Chalo, I dash, you are given relation. First of all, you have to find what is angular speed in case 2. So for that we can use law of conservation of momentum. Law of conservation of momentum. Sorry, angular momentum. Angular momentum. That is L is equal to L dash. Angular momentum in case 1. Angular momentum in case 2. L is equal to I omega. It is I dash omega dash. You are given this relation, that is I dash is equal to 2I. It is 2I omega dash. I cut. So omega dash is equal to, it is omega by 2. Means if moment of inertia becomes twice, angular speed becomes half. Simple. Okay, now put value in this equation, that is half 2I, here it is omega by 2 whole square, so is equal to 2 cut, it is I omega square by 4, and I omega square by 4 means it is half I omega square, means it is half of K by 2. It is half of K, that is K by 2. Simple. Okay, so yes, this question is easy if you know what is equation of kinetic energy. What is equation of kinetic energy? So now next question. The center of mass of 3 particles of mass is 10 kg, 20 kg and 30 kg is on origin. So first of all I will write this. See, the center of mass of 3 particles. First of all you are given 3 particles. Okay. M1 10 kg, M2 20 kg, M3 30 kg, and their center of mass is on origin, means our center of mass is 0, 0, 0, or you can say only 0. So for this you can write equation, that is our center of mass is equal to M1 R1 plus M2 R2 plus M3 R3 divided by, here it is M1 plus M2 plus M3. But as our center of mass is equal to, it is 0, 0, 0. Here it is 0, 0, 0. Is equal to, okay, it is M1 R1 plus it is M2 R2 plus it is M3 R3 divided by M1 plus M2 plus M3. It will be 10 plus 20 plus 30. It is 60. It is 60. And if you multiply 60 this side, then it is nothing but 0. So, oh, here M1 R1 plus M2 R2 plus M3 R3 is equal to, you can write directly as 0. Yes. Now what is question? Now where should one place a mass of 40 kg? So that center of mass of system is equal to 333. Now where should one place a mass? Means you are given already 3 particles. of 10 kg, 20 kg and 30 kg. You have to add one more. You have to add one more particle having mass 40 kg, so that center of mass of the system is equal to 333. So now system is of, yes, now system is of 4 particles. 4 particles. Yes, having masses M1 10 kg, M2, what is M2, M2? It is 20 kg, M3, it is 30 kg, and M4 is equal to 40 kg. And now their center of mass, means our center of mass, is equal to 333. Is equal to, it is 333. So now what is equation? Now equation you have to write is, okay, R center of mass is equal to M1R1 plus M2R2 plus M3R3 plus M4R4 divided by, here it is M1 plus M2 plus M3 plus M4. And now new R center of mass is, it is 333 is equal to, here it is. You have to find where should one place a mass of 40 kg. A mass of 40 kg means you have to find R4 is equal to question mark. Now yes, you may ask me one question, sir, R4 you have to find, but you are not given R1, R2 and R3, then how to find? Yes, you are not given R1, R2 and R3, but you know this relation, okay, M1 R1 plus M2 R2 plus M3 R3 is equal to 0. So I can replace this by 0 and I can only write here it is M4 R4 divided by M1 plus M2 plus M3 plus M4, 10 plus 20, 30, 30 plus 30, 60, 60 plus 40, it is 100. It is 100. Clear? Okay, so now I can multiply 100 this side, so it is 300, and this I can multiply 3, or I can say 100 here it is, okay? It is 333 is equal to M4 means it is 40 R4. So therefore R4 is equal to, it is 100 by 40, here it is 333, 0 cut, 0 cut. Clear? Okay? Okay, and now therefore R4 is equal to, it is, R4 is equal to, it is, now you can easily understand this. Okay, yes, it is your answer. Okay, so yes, it is how to solve questions. See, it is one good question, okay, in which you have to use your brain. Okay, yes, as you are not given R1, R2 and R3, then how to put values or how to put data about R1, R2 and R3. You have to use this one, this initial definition. Clear? So yes, dear students, for today in chapter number 7, this is it. We will see some more questions in next lecture. Okay, tada.